You will recall that the coefficients in the balance equation allow us to relate the moles of reactants and products involved in the reaction. Okay, so if we know how to figure out the moles of a particular reactant or product that was involved in a reaction, we can figure out how much of the other reactants and products are also involved. Okay, and the way we figured out moles previously was by determining the mass and using the molar mass to convert grams to moles, and then we can figure out grams from moles by multiplying moles by molar mass. Now that we've learned about molarity, we've got another way to determine moles, and that's just molarity times volume gives you moles. Remember, molarity is moles over volume, right? So molarity times volume gives you moles. So here's an example of a stoichiometry problem that involves solutions, in which case you're going to need to deal with molarity. So here's an example. Consider your neutralization of sulfuric acid by sodium hydroxide, H2SO4 plus NaOH. Okay, this is a neutralization reaction. The H plus from the sulfuric acid, the hydroxide from the sodium hydroxide gives you water, and the other product you get is the salt, sodium sulfate. Okay, and if you look at the coefficients in this balance equation, you have a 2:1 ratio for sodium hydroxide and sulfuric acid. Now, typically, you would carry this reaction in solution. So, okay, notice this is an aqueous solution. How many moles of sulfuric acid will be neutralized if you were to use 25 milliliters, use up 25 milliliters of 0.2 molar sodium hydroxide? Okay, so this is a stoichiometry problem. Given the amount of sodium hydroxide that was consumed, you're asked to determine the moles of sulfuric acid that's also consumed during the reaction. So all you have to do is figure out moles of sodium hydroxide based on the amount of the molarity and the volume of your sodium hydroxide solution. So you say moles of sodium hydroxide is molarity times volume. Molarity of your sodium hydroxide is 0.200 moles per liter. Okay, that's sodium hydroxide per liter of solution times 25 mils of solution. So you have 25.0 times 10 to the negative 3 liters. Okay, so liter cancels out. Notice this 10 to the negative 3 is milli, right? So milliliter is 10 to the negative 3 liters. So that gives you 0.2 times 25, that's 5, and that's 3 sig figs there, so that's 5.00 times 10 to the negative 3 moles of sodium hydroxide. Okay, so now that I know moles of sodium hydroxide, I can use the coefficient ratio, stoichiometric coefficient ratio, to determine moles of sulfuric acid. So all I have to do is say moles of sulfuric acid is equal to moles of sodium hydroxide times, according to my balance equation, 1 mole of sulfuric acid reacts with 2 moles of sodium hydroxide. So 1 mole of H2SO4 for 2 moles of sodium hydroxide. And if we did this, we can say, okay, that's 5.00 times 10 to the negative 3 moles of sodium hydroxide times 1 mole H2SO4 over 2 moles of sodium hydroxide. Moles sodium hydroxide cancels out, and you get an answer of 2.50 times 10 to the negative 3 moles of H2SO4.